Hi everyone, how's everybody doing? Welcome to 202. As you may have noticed, I don't have my camera on. Uh, I'm still not 100%, and so I did okay with my first class, but at some point I did start to feel pretty bad and kind of wanted to just lean to the side. So yeah, I'll keep my camera off and hopefully I get through the entire class, but we'll see how I feel. Okay. Either way, I think we're in a good spot because even though your test is a week from today, all of the content that will be on the test we've already covered. It actually ends on recursion. So if anything, I can answer questions on things before recursion if you'd like me to clarify anything. Obviously, I don't know exactly what will be on the test because they're still making the test. They'll share that with me soon. But we know what we did pick as the topics. So all the linked list stuff will be on the final, but not in the second test. But yes, it will be a week from today. And yeah, from another logistics perspective, I am gonna stay a couple of days extra here. I changed my flight because of the sickness thing. I wanted to avoid issues traveling sick. So yeah. So but that doesn't affect anything. I'll travel on Veterans Day, so it's a holiday anyway. So yeah, that works out because that way, otherwise Saturday I would have not been able to answer questions when I'm flying and whatnot. So that works out. I did post the assignments for the recursion and the linked list assignments already. Those are available now, so you can work on them. I encourage you to work on the recursion one particularly before the exam, uh, just because it's a good refresher for the test material, I presume. So, yeah. Hold on. Let me drink some water. Okay, so you watched already a video on linked list, and that video is pretty thorough, right? Actually, well, did you watch a video on linked list or did you watch a video on recursion? I watched a video on, yeah, on linked list, right? Just anybody confirm with me on chat. I want to make sure that we're on the same page. Yes, perfect. Okay, so I do have here the notes from that video. And so, you know, you already have kind of the basics of what a linked list is. You have the concept of basically a different way of storing information, no longer in an array, but in this new data structure that is using pointers. And the big thing about it is how quickly you can access it. Or sorry, not access, my bad. The big thing is how quickly you can insert and delete from it. Because, with an array, you have to resize the array, make a brand new array. And here you can just like keep allocating memory on the fly as you insert things. The downside is that in an array you can access any spot in it immediately, whereas with a linked list you can't. You have to kind of walk through the list. And so I show some code. Let me I can copy and paste it just to refresh your mind from that video. Copy and let me just zoom out so I can paste nicely. So here is the hold on, there we go. I think right around there that works. So here you have the two main parts of the linked list in terms of coding are going to be the node itself, which contains the data and the pointer to the next node, and of course the linked list class itself, which contains a pointer to the beginning of the node and then any operations that can happen on that linked list. Now, the way you code the node in this case was we did a template, but you don't have to do a template per se. Like you can just say class node, and then you have the two main things that you must have, which are the data component, which whatever data you want to keep, or if it's template, then you do template, and then your pointer to another node. Now this might be a little bit weird that you have a pointer of the same type versus like an object, which we know would not compile. But that's okay because this is just a pointer and it's not pointing to anything at the beginning. It's only after you allocate it or you set the pointer to something that it points to something. So in a way, if you look at that node, what it looks like is this little box with the data and the pointer, which is currently pointing to null, which I use the circle to represent. The other thing I highly encourage you to do, and this is more of like the optional but highly encouraged thing to do, is to have a constructor. And frankly, you could have a destructor, but at least have a constructor. The constructor's main job is going to be to initialize your pointer here to something. That can be as simple as setting it to null, or it can be as complex as having a custom constructor that passes in the next pointer's address and sets it there, or like we're doing here, where we're passing the data value so that we can assign it to data immediately. Now, data here is not dynamic. However, more than likely everything will be dynamic when it actually gets compiled, but it's technically not dynamic here. And so, because it's not dynamic, you don't need to allocate it with new or delete. So, but if you did want to make this actually dynamic manually, and you had a new call here, that's when you really want a destructor and even a copy constructor. Rule of three, which is your constructor, your destructor, your copy constructor, and your assignment operator as well, overload. So that's your node. You saw all of that. We declare some nodes. You link them together by setting the pointers. I show you all these memory of how, unlike an array, pointers of nodes can be all over the place in memory, making this weird ordering, which is why the access time is abysmal for a linked list. So if I recall, I ended the video talking about the insert function and the 4 different possibilities of where things get inserted in a linked list. So what I'm going to do is I'm just going to copy that over here. Right there. And let's talk about them. So what are the 4 possibilities that you can insert into a linked list? The first one and most obvious one is that there's nothing on the linked list. Now, before I go further, let's actually make sure that I show you, because I don't see it here, is code of a linked list class. Just so that when we talk about things like head and tail, well, head primarily, that this makes sense. So when you're building a linked list class, I'm just going to call it LL for linked list. You can make it templated, of course. In fact, if you want, I'll make it templated so that it matches the stuff up here. Plus, it's good review for the midterm. Like that. There's basically one major component that you have to have in a linked list class. And that component is a pointer of the node class. This is templated, so you need that node T like that. And this has a traditional name to it called head. Okay? Lowercase, uppercase, whatever. But it's called head. And what that pointer is going to initially contain, and you can do this if you, and by the way, it's a pointer, so a couple of things that I missed here is that I should be using a asterisk in here. Is that going to work like that? Yeah, that should work like that. So as long as I do that, I want to initialize it to null. I guess you could try inline initialization. I think that should be okay with templates. Famous last words. Maybe you got to do this in the constructor, but initialize it to null also. Okay? What this is for is a pointer that is going to sort of link up to your linked list. So if that's your linked list, then you link up to it like that. Okay? That's why when you see this H here, it represents the head. The other big thing that you should have on a linked list, I mean, this is the only component, but like from here on, the other useful things are going to depend on the type of linked list. So you might see something known as a tail. The tail is just another node pointer that usually points to the end of the linked list and can be useful to quickly access it. Because remember, with the linked list, you have an issue, and that issue is that you can't just go immediately to any spot. Okay, you have to like manually traverse it. And so because of that, it might be at least beneficial to have one pointer at the end so you can quickly go to the end if you want to put more things in there and whatnot. Okay, so you might see that as well in there. And then, of course, you're going to have a bunch of operations on your linked list that you want to do, such as inserting. If you want to insert something into your linked list, you may have a function called insert that is also templated. And so on. And that's what we're going to show you how to do, that insert function right now. But you could also have things like delete or remove, free, like a deallocate function. Well, you might also want to have a destructor of the linked list class. Your constructor might just be to initialize something like the null pointers, which we already did, and so on. But I'm just saying the real core things are just going to be, well, at the very least, the head pointer. And then second to that, maybe the tail pointer. But this is the one you really need. So like the lines in pink/purple, whatever color this is for sure, are the ones that you should have on the linked list class. Okay. So now that we say of that, we can talk about how do we insert into the linked list. So we have the four possibilities. The first possibility is that the linked list is just empty. Like there's nothing in it. Brand new class. And that's nice because if it's empty, all we got to do is just take that head pointer and assign it to a new node that we allocate. Bam, done. That's it. That's all you got to do. Very easy. Can be done in a couple of lines of code. I'll show you that code. The other three are not so easy, but they're not hard. I mean, they take a little practice the first time you do it. And those are, we have an existing list, or the list is not empty, as you can see by my little control flow here. Okay? If the list is not empty, then you have to decide where you want to insert. Or if you don't care, you can just insert wherever. But suppose that you did care where you want to insert. Well, if you do care, then there's three options. You can insert at the beginning of the existing list, you can insert at the end of the existing list, or the one that's harder, I suppose, relatively harder versus like these, is inserting in the middle of the list, which means at least there's one or more items before or one or more items after what you're trying to insert, which means you're going to have to modify two pointers uh, versus technically one, I suppose. Okay? And so, well, yeah, two instead of one. Yeah. Now, how do you actually do this? Again, I'll show you the code in a minute, but for now, I'll just explain to you conceptually. When you insert at the beginning of the linked list, what you do is you have something like this already, and you want to insert this. So the way that looks like right now would be your head pointing there. What you need to do is you first, before you do anything, is you first go ahead and you create the new node you want to insert. And you have some sort of pointer, some temporary pointer that is holding that. What you're going to do now is you're going to take the next pointer of your node, so the pointer right here that's pointing to null, and you're going to copy the value of head, which is pointing to the first node, and copy that over to this next pointer. So you're going to make that point to what head is pointing to. After that, it's just a matter of updating head from pointing to what was the previous first one to the new first one, which is basically what TMP is holding. And then you can just, don't worry about temp. delete, set that pointer to null, or just let it disappear when the function ends. That's how you insert at the beginning. Inserting at the end is also particularly simple. All you got to do is get to the end of the list first. That's when a tail pointer comes in useful. But even if you don't have it, you can just use a loop to traverse to an existing linked list until you get to the null at the end. When you get to the null, well, you've already gone a little bit too far, because what you really want is the pointer to the last item. So how can you go one past the last one? Or sorry, how can you get the one before the last one? Well, you can just look ahead by using your next. Again, don't worry. I am going to write code for all of this. I'm just, you know, I'm trying to do what you should be doing when you're writing code, which is first plan your code out, get some scratch paper and scribble it in. And then when you got your plan, then you start coding because it's 10 times easier. So that's kind of what I'm trying to do here. So you're going to have this temp next pointer. And when that's equal to null, that's when you know that you're at the last node. When you get that, then you know that what you need to update is that temp next pointer, and you need to update that with the new node that you're going to bring in. So like if this is the new node you're bringing in, then you want to update that next pointer and assign it to whatever temp is holding this node. So you just do temp next gets null. After you do that, what that's doing here is it's making this point to this node. Then all you got to do now is nothing. Yeah, you're done because there's no tail pointer. If you had a tail pointer, you would have to update that. But because you don't have a tail pointer, then you're done. Yep, because you already initialized this to null in your constructor, so you don't need to do anything. So yeah, that's easy. The middle one is tricky because whenever you get to the spot where you want to insert to, then you gotta basically face this situation. So let's just put 3 nodes here, or actually 2 is enough. And let's just say you want insert between these two. What you need to do is you need to create your node as usual first, set it to null so it's with the constructor, and now you want to update this pointer here and make it point here. How you do that is first you got to traverse this linked list and get to this node. We're going to call this previous node. Okay? Once you get to that node, and this of course is being held by a temp as usual. I mean, what I'm saying with this being held by a temp is because at some point you're going to do something like new temp gets node and then whatever you're inserting, like 22, right? So that's what I'm saying when temp comes in. But when you do your new call, or sorry, this is not Java here. Temp gets new node, like that. All right. So when you do that, that's what I'm saying with temp. Okay. So you have your temp node here, and what you want to do is you want to copy this value in here so that this points like that. So once you get to prev, then you know that prev next is exactly what you want to copy into temp next, which is this right now. So then you use that. You just assign it. That line of code is going to do this line, which is good. That's one of the two. The next one you want to do is this one. You want it to point that way. So how do you do that one? Well, you take previous next and you assign that to point to temp, right? Once you do that, now this link is gone. And you've achieved that because this is also gone now. And there you go. You're good to go. Okay? So that is all there's to it. Are we all good? Are we all ready to code, or do we have any questions? Otherwise, just tell me I'm good or something. I just want to make sure the stream is running too, right? Because otherwise, like, Remember, I'm only streaming. I'm not recording locally. I have to download the stream, so I want to make sure it's good. Okay, awesome. All right, so time to code. So this is like a nice thing about 202 that I can actually code the linked list from scratch. But whereas in 302, when we're talking about data structures, you don't really have the time to code all of them because you run through them so fast. So that's nice. We're using the online GDB again. Although for that, I think I had the zoomable thing. Wait, this is the zoomable one. So maybe I can make it a little bit more. So no, leave it as it is. Just go. Yeah, this will be the last time. There we go. Okay. Just so it's more readable. Okay. Would you like me to make a templated linked list or not templated? That is up to you completely. Whoever at least first responds. First response gets the decision. We don't particularly need to make it templated, but I mean, it might be a review or doesn't matter. It's up to you. Not templated. Okay. Sounds good. All right. Everything is working fine. All right. So the first thing we want to do is write the node class. So I'm going to make a node class. And in this node class, I am going to go ahead and write the node pointer, which I'm going to call next. And I'm going to write the constructor that I said that at the very least, what I want the constructor to do is set the next pointer to null, like that. Okay. I also want to make a node constructor that can initialize something in that. So since we're not making a templated, we're just gonna make the node class hold cars. Let's just do cars. Just so, we'll use numbers. So cars might make it interesting. So not like vehicles, but like actual characters. And we'll call it data. Um, we could also make the data dynamically allocated or not dynamically allocated. I'm inclined not to make it dynamically allocated, but I am more than welcome to switch it if you'd like. But yeah, so car data as a second constructor. In this case, we're gonna make next also null. And we're gonna make data be set to the data there. By the way, this data is coming from here, and this data is this one. Okay, so like I'm basically if this bothers you with the names, that works too. Okay, but the other one would compile and run fine. Um, yeah, so those are the two constructors, and that's literally the same thing that I had before, except not templated. But yeah, okay. So that's really all there's to it here. I mean, obviously you want to make this public of some sort so you don't run into problems, but you could also like make this private, like make the actual data private or make the pointer private to avoid issues, and then like make a setter and getter, all that stuff that we learned in like the beginning of the semester. But sorry, I'm fixing the headset. But for now, we're not gonna do any of that. We'll just make everything public. In fact, we could have made it a struct even. Okay, now linked list class. Obviously, you want to declare first the node class before the linked list class so that the thing compiles or at least put some sort of external prototype. So yeah. as for this, like I said, really the big thing that you need is a pointer called head, and that's it. Okay, so also make it public for now. Although you typically, again, want to make it all private and whatnot. I am not going to make one single insert function this time around. I want to make 3 of them uh, because I want to show you that. And then we can make a combined one that we combine all the 4 choices. So I'm going to call it insert empty. I'll make him outside the class. I'll just put the prototypes here. And these will be void. Then we're going to do void insert beginning. That's a long function name. Okay. Insert end. And then insert at. Because this is the middle one. Okay. So these are the functions. And of course, I need a parameter here, which is what I'm inserting. So just some color. Okay. And once we do all of these, then I'll actually just make an insert function that is going to combine all of them. But in this case, I'm going to use, how am I going to pick which one to insert at is I'm going to make it like insert sorted. So I'm going to insert in the spot alphabetically where it belongs to. I gotta get used to the control S thing. Okay? And then, next time and for the next few days, we will do also the deletions and double linked lists and all that. Okay, so let us begin. I'm just gonna do empty ones for now. And then just do them all. Oh, I needed to paste it one more time. Okay. So let's make sure everything is going okay. We need line 11. L has not been declared. Oh, I don't have the word public here, like the class. Okay. So again, we're gonna put them. These are already set in the same order. No, I guess middle one was technically in between, but I'll leave it like this. But yeah, so we can reference now back to our guide here. So we're gonna start with the insert empty, where we just basically set it to head. So let me grab my little laser pointer. So we're gonna do this one, where all we gotta figure out is when there's nothing on the list. So all we gotta do is literally set the head to that and call it a day. Obviously, in the real world, you'd only really do the insert sorted or like insert at. But I'm showing you simple steps here. So insert empty would be as simple as saying head get our new node. Now we gotta allocate our new node. We could do that in a new function, but since we got the constructor, I could just do it in a single line, and I think that's nice enough as it is. So we're gonna say node temp gets new node with whatever car we're passing in. Once the node's created, we just assign it to head, and that's it. That's the entire function. If we want to test it really fast, we can make a linked list object called list1, and then we can simply say list1 dot insert 22. Or sorry, it's a car, so H. One more function I'm going to go ahead and add in here so that we can see the linked list is a print function. Otherwise, we can't see the list, right? So that print function is going to have to evolve I could give you the final version now, which is just a loop, but I think that won't make as much sense right now. So for now, my little simple print function is just going to print the head, just so we can test if that piece works at least. So this is going to see out head data, okay? And if this works, then at least we should see an H print out. And you can make this super cool by overloading, by the way. I could totally overload like the OS stream operator here just so I could see out it instead of calling print. But I don't want to waste too much time with that right now. So I'll call it a day with that. Yeah, simple. And head was not declared in the scope. Oh, I forgot to put the scope resolution operator. Void print. Class L has the memory name. Insert. Oh, yeah. Insert at empty. Okay. As you can see, it's pretty bare bones, but we do get the H printed. Okay. So we have a linked list with one item, and that item is a head. Okay, we know that works. Let's try the insert at the beginning now. So insert at beginning is for when the list is not empty, but we still want to insert in front of the existing items of that list. So that's option 2 here. Okay, so that's when we want to do this right here. So to achieve this power, what we are going to be doing is we are going to be taking the current existing head pointer value and then assigning that to the temp node. But as before, we have to allocate the node first. So we can just copy and paste that from above. And now that we've allocated the node, we can start to manipulate it. So right now, temp next is equal to null, and that's where we want to point to the existing head. So we can do that by saying head gets temp next. What we've done now, as here, I know what we can do. Let me bring up the coding and iPad. There we go. Oh, that looks terrifying. Let's not do that. I'll just swap back and forth. Okay, so let me tell you what we've done so far. Okay, so we got our existing linked list. And we have the head pointer. Okay, we have our brand new node called temp. And what we want to do is we want to link it up front. So when I wrote the line, node temp gets new node C, I create a temp. And when I say temp next gets head, this is next right here. These are always all next, right? And these are all data. So I'm saying this arrow, update that to point to whatever head is pointing to. So that is going to be here. All right, very cool. That's what we wanted. Now what do we just want to do? Well, we want to update. This is no longer the head of the thing. This is the head of the thing. So go ahead and set it that way. So how do I do that? Well, I got to assign head to something, and that something is what was pointing there, which is temp, as you can see. So that's literally the line of code that I got to write. Of course, it's head, not H, but yeah. Okay, that's it. Now I'm done with that. All right, very cool. So next from here, we have insert at the end. But okay, let's test it actually. So let's put an E. That E should show up before the H because it's inserting at the beginning. So Run it and see. Oh, we only see the E. That's because our print function is only printing the first item. Let's have it print now the first and second item. How do I do that? Well, I can say head, the next spot after the head, and the data of that next spot. So that is going to print out both items. Oh, it did not. Why? Oh, it printed them on different lines. That's why. That's because of the end line. There we go. EH. Okay? So that is working too. Next, let's try inserting at the end. So let's say we want to insert something at the end of that. This is where it's more fun because we want to traverse the linked list. Now, how do we traverse a linked list? Many different ways. We could use a while loop or we can use recursion actually. I'm going to save the recursion example for the print maybe. I'll leave it at the iterative version for this, and then we can do the recursion for the print. So yeah, in this case, as usual, you're going to start with your new node creation, and now you're going to write a while loop that is going to traverse this linked list all the way to get before you get to the end. So start out by getting a brand new pointer. We're going to call this cur for current, and I'm going to assign the head. So that way I start pointing at the head. So from a visual perspective, what I am saying to do here is I am saying take my current linked list that I have here, which I only have, well, let's add one more item just so you can better visualize this. And I have my head pointer, and I have my temp node. Okay? I'm saying, okay, copy this value and make another pointer called cur, which I'll just put a C here. Okay? Now what I want to do is I want to work my way all the way until I get to the end of this. The way I'm going to do that is whatever cur is pointing to, because it's pointing to a node, we can get the next node by saying next. So while that value is not null, then keep updating it. So if cur next is not null, then get the next value of that, which would be cur next next. And so on until we get to null. Okay? So while cur next is not equal to null, or simply you could, I mean, in theory, you could just say while cur next, because that would be, if it's null, it would get out. So either of those could work. But I think the previous one's a little more descriptive when you're first starting out. Plus, you use null PTR instead of using null. Uh, so yeah, while cur next is not equal to null, go ahead and just update what cur contains, or what cur next contains too. But in this case, it's a little more elegant way of doing it. Okay? There is one catch to this, and that is you don't want to call this function if cur is equal to null, right? If it is, then that means the list is empty. But again, we're making the assumption that the list is not empty because we have a separate function for that. We will fix all of those assumptions when we do the insert sorted version, okay? So yeah, these are all sort of flawed in that you shouldn't call them in the wrong situations, but we're not worried about that for now, okay? I guess just to be extra safe, we can say if cur is equal to null, we can return, so it fails and like a bad call. Okay, that's what I meant. Okay, it's not Python. All right, once you do all of this, when the loop finishes, then you know that cur next is equal to null, which means that you're at the last node. Now that you're at the last node, cur itself is pointing to that last node. So we have a situation like this. Well, again, all we got to do now is basically say this pointer here, which is represented by current x, we want to make that point to temp, so that current x gets temp, and then we are good to go. We don't have a tail pointer to update, so that's all we got to do. Yep, that's it. So now let's go ahead and update this print function to actually print an entire list instead of printing individual items, so that we can look and see if this all worked out. And of course, let's just put in here some letter. So let's put in a T. So we'll do list1 dot insert at end T. Okay, so how do we print this recursively? Well, to print it recursively, you want to have a pointer that you can manipulate. So that's going to have to be a parameter in your function, or you need to have a temporary pointer in your class. So we'll just make it a pointer in the function. So we can have a secondary print function called print recursive, and that gets a node pointer passed into it. So what I'm going to do is I'm going to call my print function. And the reason I'm not doing it directly is so that I don't have to pass the head pointer here as a parameter. This could be like an internal private function. In fact, here, let's just make it private already, so people don't pull it with bad calls. Print recursive and the node pointer here. And all this is going to do is it's going to call the print recursive function, but it's going to pass in the head pointer. So now what this does is it's going to print out. Remember, our three things we have to have in recursion are the base case, the recursive case, and the do something. So the base case is going to be if cur is equal to null. That means that we're done. So at that point, we are done. So we can just return. Let me just stretch out here a second. Okay. Getting tired. The other one is going to be the recursive case, which would be to say, okay, print the next thing in the list. So print recursive cur next. And then our do something, which is basically to print out the current value. So cur data. And in addition to that, I'm going to print out some cool arrows, so it looks more like a linked list. Okay, something like that. I can even have a case for like the first time you call it, so like right before here, where I have like link list, and then like that. So now if I do all of this and I make sure I don't screw something up, uh, let's see. No, it's not declaring the scope. Oh, I forgot to put the PTR on that one. That's line 38. All right, so we can see that it's working, but I got to get rid of the line feed. I actually didn't want a line feed here. I do want a line feed at the end, so that's something I could put in my base case actually. So the last thing that gets printed is this line feed. Oh, well, it's not Python, so multi-line if statement needs curly braces. So we can see that we got the E and the H. We're not getting the T though, so something's wrong on that T. Let's try to see what happens. So if we go and look at our insert end function, we create our node, we have our head curve pointer, that curve pointer works its way all the way to the end, and then cur next gets temp. So that's weird. It's not printing it. maybe our base case here is messed up. So print recursively, cur data, cur next. I'm not sure, but this thing has a debug, so let's see if the debug will save us. Oh, this run GDB. Fancy. Okay, so we hit the breakpoint, and let us go into steps. Oh no, we have start. Okay, so we're gonna step into that. We're gonna see that get inserted. Okay, got inserted correctly. Insert at the beginning. Got inserted correctly. All right, let's see. Insert end. So it gets called. Okay. Gets allocated. Yes. We get cur gets assigned the head pointer. If cur is equal to null PTR, don't do anything. Ooh. Ah. Yeah. So what is the issue, guys? Oh yeah, you also wrote it in the chat and I didn't see you either. Darn. I'm sorry, I didn't look at you. I was so focused on the issue I didn't see that. But yes, you were correct. It was missing the braces. So that is a problem, but I don't think that's gonna fully fix it. Actually, oh no. Yeah, that will probably fix it because that's just calling returning anyways. So that could actually fully fix it. Yep. Awesome. Yeah. Not Python. Yeah. I gotta stop coding in Python, but it's just so much better than C++. So yeah. Okay. Well done. All right. We got 2 more to go in 30 minutes. We should be okay. But maybe I want to do the deletes too at some point. All right. So now we go for the middle one. Now the middle one, I didn't think about it like too far. We need an index for that. So we got to make sure this only gets called in the right situations because the insert sort is the one that will deal with any potential invalid stuff. So let's put in an index for this. That's a parameter. It's going to represent like where we want to insert it to. Okay, and maybe we'll modify it later so that it inserts there but also handles the other situations. That'll be the most ideal. So the first thing as usual is, surprise, is to allocate the information. And then from there, since we want to go to this spot, then we could use a for loop for that. Again, this is only going to work if there's enough members of the list. Otherwise, it'll crash. So we can say for int I is equal to 0. Oof, I don't like I don't like that naming convention there. So instead we'll say nothing for the first one. We can actually use a variable there, yeah. So you can say I is greater than 0, I minus. Yeah, that'll work. Now we don't need a new variable. That looks kind of ghetto for a for statement, but it'll work. We're just using this int I, which is like if it's a fifth item, then this will count down, basically. So let's say it's the second one. So then we're going to run at 2, run at 1, and then it would not run at 0, so it'll run 2 times. Yeah, it'll work like that. Okay. So we just want to do the same thing we did with the insert at the end. We want to have that same loop. Okay? Which is basically, where's the loop? Ah, here it is. So you just want to have the exact same loop. Okay? So while cur not is not equal to null, keep going. So in this case, we just do cur gets cur next, as long as we declare a cur to be the head pointer, like that. And the reason we don't want to change the head pointer itself is because that's our only link to the beginning. And if we lose that, we have no access to this thing. We just created memory leaks. Now, if you're like, oh, I don't like this, what if we hit a null here? Then you could use a while loop and then actually do the count inside. That could work as well. I'm going to do that when I get to the insert sorted or I upgrade this into the better version of this. Because otherwise, this could potentially crash if the index is higher than what exists in the list already. Okay? So when you do that, you're going to be at the right spot to insert. So what that means is that, let's do the picture time. So when you run this, you will basically be here. So let's just say we're running that and we want to insert at, oh, that's the other thing. The way I have the index set up right now is starting at 1, which is like, ooh. So maybe I should have set it to start at 0. Uh, if I want to do that, then I can just say greater than or equal to 0. Okay, so now we got more like classical indexing style. Okay, so let's say we want to insert an index 2. So after the loop finishes running, cur should contain, so cur is there for 0. Actually, I can leave it as I had it before with just a greater than, because then that way, if it's 1, it just runs once. It gives me this. Yeah, okay. So I'll leave it. I'll switch back so you can see what I did. I will leave this as I had it originally, as greater than 0 instead of greater than or equals to, because then if you feed it a 0, that for loop never runs, and so my cur is pointing to the first item already, which is good. If it runs once, then it points to this one, and if it runs twice, as is the case with 2, then it'll point here. So now I'm trying to insert at index 2. But that's the other thing you got to decide. What does it mean to insert index 2? Do you want to replace index 2 or do you want to insert after index 2? That's another thing. Okay? So I don't know what you guys prefer, but I'm thinking like insert after index 2, like existing index 2. But I could also shift it. Some people, for some people, that may be more of the logical meaning of that. It's really up to whatever you want it to mean. I guess I'm trying to remember what it would be in Python if you use the insert function. If you would shift things, I think you would shift them in Python. So let's stick to the Python style and shift it. So when I say insert index 2, what it's going to do is it's going to insert like right here. And if I want to do it that way, then I'm going to actually subtract 1 from the number that I want to kind of move along. So instead of saying I is greater than 0, I'm going to say actually I is greater than 1. Yeah, that'll work as long as we're not inserting at the beginning. Yeah. Okay. So having said that, I'm going to go ahead and show you. So if that's the case that I'm inserting greater than 1, then my counter, if I want to go, it's going to go 1 less than that. So it's going to stay at 1. So it's going to be pointing there. So because I know it's pointing there, what I want to update is I want to update C next to point to the new node, which we'll again, as usual, call temp. And we have temp next as well. Okay, so I'm going to assign that there, and that's going to change this pointer from here to point to my new node. And then I'm going to change temp next, which is currently pointing to null, and I'm going to assign what C next was pointing to before. Now, I hope you catch something bad that could happen here if I do this in the wrong order. That's basically saying link that here. Here's the problem. I have overwritten C next right here before I ran this line. You can run into problems that way. You can see live. So if you do that, then you're gonna just like make a circle here that could go anywhere. you want to make sure that you update this first before you update this. Okay? So let us go ahead and do that. So the first thing I'm going to do, as I said, is I'm going to switch this from 0 to 1, since I want to do it before, Python style. And now, let's go ahead and do that. So I'm going to say cur next. I want this to get assigned to temp, but I also want cur next to copy that value into temp next, like that. Okay? And I have to do it in this order, otherwise it doesn't work. It's like swapping two things. You want to copy into somewhere else before you do the swap, otherwise you overwrite it and you lose it. That's it. That's all there's to it. I know it's like a lot of thinking for 2 lines, but that's how code usually goes. You gotta, the more advanced code you do, is not that you write more code, it's just you write smarter code, which takes longer to do. So, yep, that is all there's to that. This is absolutely not safe at all. There's no checkings, nothing. But again, we will make this is going to be like the better function of everything. We're going to take all of these functions and we're going to apply them into this system. Okay? But first, let's just test the simple version of that. Now, we don't have a lot of things in here, so I'm going to go ahead and throw in a couple insertions. Oh, did I write C actually? Oh, I did. Darn. Good catch on that. I'm going to throw in a couple of more letters in here. I don't have to make them alphabetical, but I've just been doing that for a while. There's a software in C++, right? I mean, if there is, I just make my own 3 lines of code, but I'm sure there is. Probably something in the like the uh, shoot, I forgot the name of it. Like in algorithms, maybe, or maybe it's just included. I don't know, but I mean, it just seems like something that would be there. All right, so let's say that we want to insert at index 2. That would, in theory, be the E, right? Like before the E. Let's see if that actually works. So, because I might have messed up the numbering. Let's insert a W. Or let's keep the alphabetical pattern going. So maybe we can put this, make this a C, so that we can make that a D. But here, I want to see the output before I show it. Just so it looks nice. Alright, that's taking a while. Very scary. Copy and paste the data, back it up in case it tries to crash on me. I think it died. Just move on to the next one. Not giving much thought. Yeah, alright. That's how you DDoS people. Alright. So, alright, let's see if this works. Alright, so we're going to put the D in. This should hopefully go right here and shift the E forward. And it did. Hooray. It got it working. Yay. Alright. One test is enough, probably. Alright. So, as you can see, that's how you do all of them. Of course, all of them individually are not very useful. What we want is to be able to have any of these work automatically. And we can do that with either using something like the insert at that we could upgrade, or we can make it so that things get inserted in a sorted manner. Okay? So let's go ahead and do the insert sorted, and then we can upgrade this insert at into a safe version. Or we could do it the other way around. It doesn't matter. But I think we do the inserted sorted first. Okay? So we could make this as a call to the other functions, but I'm going to make it a standalone function. All right, so here we got something that we were trying to insert. And by sorted, I'm saying alphabetical. So the first thing we should do is we should see if the list is empty. And if it is, then we can go ahead and insert it at the beginning and call it a day, right? Just like we did it before. So we can check that by doing it the same way we did before, right? If head is equal to null, well, we didn't do that check because we We assume that to be the case, but the code is going to be the same as that function, which is literally just head gets temp, right? All right, very cool. What's the next thing? All right, if it's not empty, then we are going to have some fun inserting into an existing list. So how do we know where it's going to go? Well, we're trying to do alphabetical, insert sorted. We're going to use, let's do ascending order just so that it matches what we're going to have already. And so what we need to do is we need to start figuring out where it's going to go. We know that the letter has to go before the one that's bigger than it, but it has to go after any that are smaller than it. And because we know that whatever it's already here is already sorted, or making that assumption at least, then we can just look at the next letter and see if it's bigger and then know that it goes before it. So to do that, we want to create 2 pointers. We want to create a current pointer. We might get away with 1, but I like to start with 2. And we want to create a previous pointer. And for now, we're making both be assigned to be the head. Okay? And so now we can say, well, let's see if what we're trying to insert is supposed to go at the beginning. Okay? So we can say if what the head's data value, if that is going to be greater than what we're currently inserting, then we know that our node has to go before, right? Because if this is saying if the letter here is a W and what we have is an A, then W should go after A. So that means that A should go before W, right? So we got to insert it already. So if the node after where we are is if by node I mean the data, if the node's data is larger than us, then we got to put it before it. Insert it before it. Right? And we know that this is in the beginning right now. So we can go ahead and just throw it in by using the insert at beginning code. So where's the insert beginning? This one. So that's all we got to do. Okay? So just copy paste it. So we're going to take temps next, set it to head, set the head to temp, and call it a day. So that solves the issue of inserting at the beginning of the list. But now, what if we wanted to insert somewhere in the middle? Then we're going to have to write a while loop and basically keep doing the same check. So why don't we just wrap this whole thing in a while loop and just say while head data is greater than or is less than temp data, right? And while that happens, then we don't need to do anything. We don't need to insert. So actually, we don't need to have that there. Okay? This will guarantee you to take us to the right spot to insert. However, this is not enough because now we want to be extra safe, and this could actually take us to potentially bad situation, right? So this is not the most ideal way to check. What we can do is what we did with the print function, which is we can use the cur, not the print because that was recursive, but the insert at, or not insert at, insert at end. Here, this one. We can do this loop because this loop is safer, somewhat safer, right? It's cur next gets cur, cur next, yeah, cur gets cur next. However, in this case, I am going to say while cur is not equal to null. And then, in addition to saying cur gets cur next, I'm also going to go ahead and say that cur or prep gets cur. Now, let me explain what I'm doing here. This is a little bit tricky. What I'm doing here is I am saying I'm going to iterate through this linked list and cur is going to keep a pointer to wherever I'm at. But previous or prev is going to keep a pointer to the one before me. So if I have a linked list like follows, I start out by having my head and my cur pointer, right? Or sorry, my cur and my prev pointer here. They're both pointing to the same thing. But after the first iteration, cur is going to move by one, but before it's going to copy the value, which is already the same, so it won't matter. The next iteration, before moving over, cur is going to copy the value into p, like that, and then cur is going to move over by one. And then when it finishes, it's going to copy the value and move over by one. So previous is going to keep a pointer to the node before the last one that I'm currently at. By doing this little trick, I can keep track of the node before and after that I'm going to be inserting to. If this loop ever finishes, then we have reached the end of the list. So now that I've done all of this, then I can go ahead and do my insertion. Okay? So this will take me to the end of the list. So I can do my insertion, but if I want to do it in the middle, then I'm going to move this back into the while loop. I'm going to switch this over from head to cur, since I'm using my cur pointer now. And I'm going to go ahead and move this cur next stuff all the way to the end of the loop. Okay? So now, as I progress through the list, I'm going to check to see if where I'm at is bigger, if the data where I'm at is bigger than where I want to insert. And if I do, then I'm going to go ahead and insert at that spot. Okay? However, here's the catch. If it's a beginning of the list, then temp, or sorry, if it's a beginning of the list, then I want to update head. And if it's not, then I don't want to update it. Okay? I want to leave it be. So I need to add an extra if statement here saying if cur is equal to head, then I want to update head to be temp. That way I avoid potential problems when inserting at the beginning of the list, okay? So anyways, now I went ahead and updated this to no longer just insert at the beginning, but potentially to insert at the middle. However, if I'm inserting at the middle, I gotta update another pointer, right? So rather than updating the head, I need to update the pointer from the node before this. So that is conveniently held in previous. So I can say previous next get temp. And that is the equivalent of what I was doing here. Okay, so that handles inserting in the middle. What about inserting at the end of the list? Well, inserting at the end of the list is only going to happen if I hit the null pointer here. So that's going to happen at the end of this while loop. So that's just as simple as finding what the previous pointer contained before the loop finished. Oh, well, it would have the, darn, but it would have previous right here running. So I can actually maybe bring that up to, I can bring that up to here. Well, I can just put it here actually. Here, I can put an if statement in the loop so that before I call that previous next, I can say if cur is equal to null ptr, it's not equal to null ptr, then run this line. Otherwise, don't run it. That way, after the while loop, previous still contains the old pointer that is not invalid, that is not null basically. So now I can just append by saying previous next, get temp, append at the end of the list. And that's all four combined into one lean, somewhat lean piece of code. Will this work? I don't know. Maybe, maybe not. We'll see. We might run into some bugs with it. There's a lot of ways that you can code it, so that's just one of them. So let's make a second list. Or actually, no, we can keep the same list that we have because it's already sorted, and we can just insert things into it. We can, we got to test some of the other cases. So let's make a second list, and let's try the. Why is autocomplete not running? Here, let's try to see if this compiles first of all. Probably not. We probably run into. Oh, it did compile. So why is autocomplete not autocompleting? Oh, I gotta write the insert keyword. Okay. Insert sorted. So first, let's just test if inserting at the beginning works by just inserting any letter. Okay. Next, we can test inserting at the beginning of an existing list by inserting a letter smaller than that. That'll test that. Then this will test inserting at the end of an existing list by inserting, I guess let's put something other than C here so we can insert something bigger. So like the Z there. That'll test inserting at the end of the list, and then inserting at the middle will be tested by something like a G. So that'll test all four cases. And then I want to insert into a bigger list by inserting into the first list maybe a, let's insert a K. Okay, and of course we want to print out both lists. So let's print out list 2 and list 1. We'll print out list 1 as is. And then let's print out list 2 afterwards. And let's see if we get what we expect. Otherwise, if we don't, we'll start printing individually. Okay, so we get, I don't even know where that's, this is who's, who, what, where, why, how of what just happened here. List 1. Why did list 1 not print out multiple times? Okay, let's comment these out for a second. See what happened here. Okay, so there's my list 1. So if I call list 1 to print again, why am I only getting it printed once? It's like overwriting my print. That's weird. Ah, maybe this is, yes. Ooh, I think this could be why. No, no, this is not why. We're not erasing it because calling print with the head pointer. I must be changing my head pointer in here. Probably this is doing it. Ah, no, it's this one. Temp next, get head. That one should not be head. That should be cur. All right, let's run the debugger again and see what's up. Ah, I see. It's getting frozen. Ah, it's sec faulting. That's what's happening. Okay. So it is sec faulting here. If cur data is greater than temp data, or cur data is not equal to null PTR. All right. If it's debugging, let's actually run that again. I want to see where it's crashing. Okay, so it is crashing in line 66. For some reason, it is telling me that current data is probably looking with a null value. Hmm. I'm not sure, but we're out of time. So what I'll do is I'll pick up debugging this next time. We probably are screwed up some assignment, and that is why. Because temp data is definitely valid because we passed that in. But for some reason, Kerr is complaining at us, and I'm not too familiar with how the debugger is running here to be able to quickly see it. So it's crashing with the T, this pointer. Yeah, I'm trying to see if this. I mean, this is a valid pointer, which has valid data on it, as you can see by that. And it is initializing these to null, so I don't know. I'll run this on my VM later and figure it out, and then we'll pick up from there. But I'm sure it's something pretty trivial that we're just missing. So yeah, I'll leave you with the mystery of what that is. So we shall pick up from here next time and keep talking about linked list. All right. So thank you all for watching and wishing you a good weekend. All right. Take care. And as for the extra credit points, you just get them automatically if you're logged in while the video is going. And I'll post this code, by the way, on chat. If anybody wants to play with it and find the bug, you can, just for fun. But yeah, bye everyone. Have a good weekend. Make sure you get some practice on your recursion so you do good on the test and finish your assignments. All right. Bye.